series on the safe handling of enzymes in the bakery supply chain. My name is Nuria Moreno, and I'm working as Regulatory Affairs Manager in the Secretariat of FEDIMA based in Brussels. And I'm happy to introduce this webinar series today on behalf of the two organizing organizations, AMFEP and FEDIMA. This joint industry initiative aims at bringing together the insights, best practices, and tools from the producers of enzymes, which are represented by AMFEP, and the users of enzymes in ingredients for the baking industry, represented by FEDIMA, with the aim to control dust exposure in the workplace. Our common goal is to help safeguard the health of workers. AMFEP and FEDIMA have been collaborating for years already on education and improvement on the handling of raw materials and ingredients that contain enzymes. One of the main outcomes are the industry guidelines on the safe handling of enzymes in the bakery supply chain, which is a document we published in 2018 and is available on our websites. This webinar series is largely based on those guidelines. As you can see in the program, this webinar series is split into 4 sessions, each one addressing specific subjects from the industry guidelines. Today is the first webinar, which will be a general introduction to the safe handling of enzymes and will also include some regulatory aspects. It is still possible to register for the remaining webinars through our respective websites and the link you see on screen afterwards. We believe that these webinars are relevant for a large audience, including health and safety managers, plant operational staff, R&D employees in the bakery sector, but also teachers in bakery education centers or other representatives of occupational health and safety organizations. Also craft and artisan bakers. It is still, as I said, possible to register, so don't hesitate to inform your colleagues if relevant. Please note that this webinar is being recorded and it will be available on our websites as a tool for continued education. Let me now briefly present AMFEP and FEDIMA to you. AMFEP is the Association of Manufacturers and Formulators of Enzyme Products. Since its creation in 1977, AMFEP has represented and promoted the interests of the enzymes industry and is now representing more than 90% of the European enzymes market and 80% of the world enzymes market. AMFEP members are producers of enzymes for the technical, the feed, and the food industry. And through its activities, AMFEP promotes the safe use of enzymes, their sustainability aspects, and their contribution to innovation. FEDIMA is the Federation of European Manufacturers and Suppliers of Ingredients to the bakery, confectionery, and patisserie industries. We currently have 12 members as national associations across Europe, as you can see on the map on screen. Our members produce a range of intermediate products to bakery and pastry professionals. Hence, we are a business-to-business sector. FEDIMA's mission is to promote a favorable environment for a sector, which in turn can support a sustainable and innovative bakery industry. As you can see in the blue box, occupational health and safety is one of FEDIMA's 4 key areas of activity, together with informed customers and consumers, food safety, and the promotion of the bakery sector as such. Our collective goal as AMFEP and FEDIMA is to work on the control of occupational enzyme exposure in the bakery sector. We do this by developing practical, user-friendly materials for the bakery sector, which combines the expertise of both of our organizations. We have developed several materials which you see listed on the right side of the screen, And these are available on the AMFEP and FEDIMA websites. And we will elaborate more on these materials later in this webinar. Before we start, a few more clarifications from our side. The information that we will present in this webinar series is furnished by FEDIMA and AMFEP free of charge and is based on the information that our associations and our members believe to be reliable. It is intended for use by persons having a technical skill and at their own discretion and risk, of course. Since the conditions of use are outside of our control, we cannot make any warranties and assume no liability in connection with any use of this information. Nothing in this webinar series is to be taken as a license to operate under or a recommendation to infringe any rules. Our materials, including this webinar, only address the control of occupational exposure among the workforce, so not towards consumers, as this exposure is practically non-existing. Please note that in cases where some brands are included in this presentation, for example, on pictures, we have only included these to provide examples to you. And there are, of course, other brands on the market that are available with the same technical functions. We as AMFEP and FEDIMA do not recommend any brand in particular. So today's webinar is an introduction to enzyme safety, and it will be presented to you by Merete Simonsen. After her presentation, there will be time for questions and answers, of course. So we would like to ask you that if you have any questions, you can submit these through the chat function during the webinar. At the end, we will collect them and try to respond to as many questions as possible. So without further ado, I'll give the floor to you, Merete.
I'm Merete Simonsen. Oh.
Yes, go ahead, Merete.
Okay. Good afternoon. I am Merete Simonsen. I am the chair of the AMFEP-FEDIMA Enzyme Safety Working Group, and I'm also working as a senior manager in the product safety within Novozymes. This session will touch upon the background for having these webinars, what sort of health effects are related to the handling of enzymes, an overall view on how to avoid such health effects, and finally, what the regulatory landscape for enzymes in the baking industry looks like at this point in time. Before starting, I would like to make a comment to the picture on the slide, which is also the picture on the cover of the industry guideline. This picture is an illustration of how easy it is to create dust in the working environment of the baking industry. It is an illustration of the problem, and this series of webinars will hopefully provide you with insight and knowledge as to how such dust creation is avoided. Enzymes are widely used in the baking industry due to their valuable and very specific activities. But what are they? Enzymes are proteins which are naturally produced in all living cells, and in all living organisms, whether human, animal, plant, or microorganisms. They need enzymes to conduct the physiological processes which are essential for growth and life. Enzymes act as catalysts, substances which in very small amounts can significantly speed up the rate of a specific chemical reaction. For example, the building up or breaking down of organic matter, such as carbohydrates, fats, and proteins. Enzymes are highly specialized in their functionality, with each enzyme acting only on a restricted number of substances and only catalyzing one specific reaction. For example, the starch-degrading enzymes, the amylases, break down starch into smaller molecules. Additionally, enzymes are beneficial to the environment as they are biological, biodegradable, and water soluble, and they are generally non-toxic. The specificity of enzymes makes them very useful in catalyzing desired reactions in industrial processes. Consequently, enzymes are extensively used in several industries, including technical and food industries, and in animal feed arenas. Commercial enzyme preparations are produced by the carefully controlled fermentation of pure culture of selected strains of non-pathogenic bacteria, yeast, or fungi. The table in this slide shows some of the applications of enzymes in baking. Fungal alpha-malase is the most commonly used enzyme in the baking industry, and therefore most of the literature on baking enzymes relates to this class of enzymes, including knowledge related to the safe handling of enzymes in the baking industry. Nevertheless, the same principles covers the safe handling of all other enzyme-containing materials used for baking. Since the enzymes are generally non-toxic, environmentally friendly, and so on, what are the reasons for having these webinars that provide guidance on the safe handling of enzymes in the baking industry? Well, as seen on this slide, it has long been known that flour dust and enzymes used in the baking industry can cause respiratory allergy. Flour dust is known to cause allergy and baker's asthma when exposure is not well controlled. The allergy from flour dust is caused by one or more of the approximately 40 different protein allergens that are natural constituents of flour. Enzymes are also proteins, and in a similar way to other proteins, they may act as respiratory sensitizers if the individuals are repeatedly exposed to airborne dust in which they are contained. Such sensitization may ultimately lead to respiratory allergy, but it is important to note that not all individuals who become sensitized to enzymes will develop symptoms. Similar risks are posed by other ingredients used in the baking industry, for instance wheat flour and other additives, which may also induce respiratory sensitization and allergy. However, it is important to note that it has been demonstrated that the potential for this respiratory sensitization and allergy can be controlled by proper process controls, product formulation, and appropriate handling instructions to prevent airborne dust and aerosols. And this is this sort of insight and knowledge that we want to share in this series of webinars. There are other forms of allergy than the allergy caused by respiratory exposure, such as skin contact and food allergy, but there is no scientific evidence that enzymes are associated with allergy caused by skin contact or by ingestion. Like many other proteins, enzymes may act as allergens via inhalation. A two-step process must take place for the development of an inhalation allergy. Initial sensitization followed by the development of allergy symptoms. Firstly, airborne exposure to the enzyme needs to occur. If this exposure is sufficiently high in terms of concentration, duration, frequency, etc., this may lead to sensitization in some individuals. At this stage, the immune system of the individual is activated in such a way that specific antibodies towards the enzyme is formed. However, the individual does not suffer from any allergy symptoms. The formation of the specific antibodies can be detected in a blood sample. It is important to note that not all individuals exposed to airborne enzyme will become sensitized. If the sensitized individual continues to be exposed to airborne enzyme, then they may go on to develop an allergy. At this stage, the individual will develop the symptoms typical for respiratory allergy, such as hay fever, and some individuals may develop asthma upon continued exposure. When this condition is due to exposure in the working environment, it is called occupational allergy. Again, it is important to note that Even among sensitized individuals, only some will go on to develop an allergy. Looking at the flow presented on the slide, it seems obvious that if the exposure is controlled, then sensitization will almost not occur. Furthermore, it is also clear that if the workforce is part of a medical surveillance program, then a sensitization will, in most cases, be detected before it develops into an allergy. The respiratory symptoms from allergen exposure may include itching of the nose and eyes, nasal and sinus congestion, and sneezing. Coughing, hoarseness, tightness of the chest, and shortness of breath are all indicators of asthma. These symptoms may occur during or after working hours, and they will disappear within hours or a few days after the exposure has ceased. Allergy symptoms may be similar to those of the common cold, and if such symptoms occur frequently at the workplace and only rarely at weekends or during holidays, they may be the result of occupational enzyme exposure. Allergy by inhalation caused by flour or enzyme is similar to the respiratory allergies that are caused by the well-known allergens like grass pollen, house dust mites, or cat dander. And the symptoms are also similar. Some individuals are more prone to sensitization than others. Atopic individuals, that is, persons already allergic to one or more of the common allergens, may develop a flour or enzyme allergy more easily than others. Smokers have a markedly increased risk of becoming sensitized and of developing allergy symptoms. In general, reducing flour and enzyme dust exposure in bakeries, flour mills, and bakery ingredients manufacturers will reduce the likelihood of work-related respiratory symptoms. Flour and enzyme handling activities that may generate dust or aerosols should be prevented to minimize the risk of exposure. This subject will be addressed in more details in the following webinars. In every working environment, employers are responsible for protecting the health of their employees. A significant part of this responsibility is risk management, beginning with hazard identification. Every type of hazard which may be potentially harmful to employees must be identified, and suitable controls must be in place to mitigate those risks. The responsibility for providing a safe place to work is not only limited to employees, but also includes other stakeholders such as contractors, cleaners, visitors, and others who may be affected by their activities. Risk management measures should always be based on a hierarchy of controls, as shown in this slide. This means that the exposure should primarily be prevented by eliminating or substituting the hazard. If this is not possible, then exposure should be controlled by isolating the hazard or reducing it by means of engineering and design. In addition, administrative controls may be used, such as safe working practices and procedures. The final measures for reducing the exposure is the use of appropriate personal protective equipment called PPE, and the relevant PPE in case of enzymes would be respiratory protective equipment, RPE. Training is a key element for raising the awareness, competence, and knowledge about safety matters. All employees must have basic training in general health and safety, in addition to their task-specific training. All workers handling powders should also have training in the potential hazards arising from flour dust and other bakery ingredients, such as enzymes, and the appropriate precautions to take when working with these materials. Training must also be organized for others who may be exposed on site, such as maintenance, personnel, external contractors, etc., and should include background information on hazards, standards instruction, and emergency instructions. Everyone attending the site for the first time should be informed and trained about the basics of enzyme safety. Training should then be continued over time on a regular basis and always when significant changes to the processes or raw materials are made. For enzymes, the hierarchy of controls can more or less be translated into the message on this slide. No airborne enzyme protein equals no enzyme allergies. If airborne enzyme exposure is in control, then only very rarely enzyme allergies will be seen. In such cases, the allergies will most probably be caused by accidents, spills, or other unintentional events. To control airborne enzyme exposure, the following elements need to be addressed: process design and engineering control, work practices, respiratory protective equipment, and finally training and education, which is often overlooked, although it is of very high importance. In this introductory webinar, I will briefly go through these elements. Much more detailed information will be given in the following webinars. Overall, the workplace should be easily accessible for engineering, maintenance, cleaning, and hygiene. It is a well-known fact that high exposures are often seen during maintenance work, for instance, when opening equipment or cleaning up after a spill. Enclosures should be designed to fully contain any spillage and liquid splashes within the equipment. Any opening or open handling will present a risk of exposure. The workplace should minimize the risk of dust formation and spillage in powder handling plants or in bakeries. Ventilation and airflow control should be in place at any opening in the process line. The examples shown on this slide, at the left you see a ventilated cabin in which the open handling of weighing adequate portions of, for instance, enzymes is taking place. Air is drawn out of the cabin through the slits in the wall at the backside. In this way, any dust that may be formed during the operation will be drawn away from the operator and into the ventilation system. The picture on the right is an example on how closed systems can be established when enzymes are being transferred from a big bag into the dosing system. Now, these are examples of good and bad work procedures. The overall goal is to prevent dust formation, and obviously there are ways to achieve this by simply thinking through how various operations are performed. In addition to the prevention of dust formation during the operation, it is also very important to think through how to prevent dust from being spread from one area to another. An important issue in this respect is to ensure that any spillage is cleaned up immediately. Cleaning up a spillage may require respiratory protection. In addition, changing working clothes frequently and not wearing dusty clothes into other areas, for instance, the meeting rooms or the canteen, is also very important. During safe operation conditions, respiratory protection is not necessary. However, in certain situations, respiratory protection is essential. This could be during open handling, opening of enclosed equipment, breakdown and maintenance, major spills, or malfunctioning of the ventilation. There are various types of respiratory protection ranging from the disposable mask to the ventilated face shield. Appropriate selection will depend on the specific facility and the situation in which it is to be used. The important consideration here is that if enzymes are handled, the respiratory protection needs to be equipped with a P3 filter. It is also called FFP3 or N100. A 2. Dust filter does not provide the adequate protection in circumstances where enzymes are being handled. Spillages do happen, and as previously mentioned, in these situations it is highly important that the spillage is cleaned up immediately in order to reduce exposure and to avoid spreading the spill to other areas. Cleaning up a spill must be done using the correct procedures. Never use a broom, high pressure hoses, or compressed air, because such equipment will simply spread the spill and increase the exposure. Instead, a vacuum cleaner fitted with a HEPA filter should be used for the removal of dry spills. If liquid spills are to be removed then depending on the situation, a soft water hose or an absorbent pad can be used. As emphasized on the previous slide, respiratory protection must be worn when cleaning up a spill. One of the following webinars will be dedicated to the subject of health surveillance and monitoring of airborne exposure. At this point, it is enough to mention that allergy prevention is all about the prevention of exposure. For this reason, it is important to know that the extent of exposure in the working environment and for that air monitoring is necessary. Having an air monitoring program will provide an overall evaluation of the effectiveness of the control measures. Identify where control measures are sufficient, that is, where respiratory protective equipment should be worn, and also to identify those working practices that are in need of a review. A medical surveillance program will help to ensure that sensitized workers are identified before they start having allergy symptoms. Timely and correct intervention can thereby prevent allergy symptoms from developing. The nature of the intervention will depend on the situation. If a root cause analysis shows a source of exposure from the equipment, malfunctioning of ventilation, or incorrect working procedures, these can be addressed and the worker can continue his job. However, in some situations, the cause of the sensitization cannot be identified. In this case, the worker must be followed closely by the medical staff, and if the health situation deteriorates, then the worker must be removed from the exposure. It is widely recognized that all employees are responsible for safeguarding their own health and safety at work, and also that of their colleagues. This applies not only to the obvious physical hazards such as trips, slips, and falls, but also to less obvious risks such as the exposure to enzyme and dust. A thorough risk assessment will lead to the development of company policies, procedures, and operating practices that mitigate against hazards as far as possible. It is very important that these policies, procedures, and practices are adhered to by all staff. As systems and methods of working continually evolve, it is vital that they are periodically reviewed to ensure that they are still relevant and fit for purpose. Any change must be communicated to all staff by the most effective means available, through training programs, posters, staff handbooks, etc. Company policies, procedures, and operating practices can be lengthy, and getting staff to read them and follow them is often challenging. It may be necessary to adopt several approaches to ensure the understanding and compliance to the whole workforce. Standard operating procedures, and instructions are the best way to guide the workforce into working practices. But it is equally important to ensure that they are continually adhered to them. The ideal is to create and foster an environment in which the regard for health and safety is so integrated that it becomes normal and natural way of working for every member of the staff. It is important to emphasize that the risk of respiratory sensitization to enzymes is solely occupational. Enzymes used in the bakery industry will be degraded during the baking process, and thereby the baked goods do not represent a risk to the general population. Additionally, enzymes are in general not associated with food allergy, that is, allergy as a result of ingestion. Enzymes can only cause sensitization and allergy via the respiratory exposure. However, new convenience products for home baking, the so-called baking mix products, do contain active enzymes. Would such products present a risk to the airborne exposure to the consumers? This issue has been studied for some of these products, and even under very exaggerated and vigorous conditions, it was not possible to create any significant exposure. It should be emphasized, though, that the outcome of such evaluation is highly dependent on the product that has been tested in the investigation. If, for example, the enzyme concentration in a product is increased, this would call for a new evaluation to make sure that the expected consumer exposure would still be sufficiently low, even under exaggerated use conditions. Generally speaking, it would be prudent to perform a safety assessment in which the level of airborne exposure is evaluated on all consumer products before launch, and, as a general principle, consumers should be advised not to create airborne dust when handling flour products, regardless of whether they contain enzymes or not. At present, occupational exposure limits have been established by regulatory agencies only for one class, the subtilisins. Subtilisins is a class of enzymes which will break down proteins. A limit of 60 nanogram per meter cube based on the at least 1 hour sampling was set by the American Conference of Governmental Industrial Hygienists, and this limit has been adopted by several countries. In EU, the REACH legislation, which covers the technical applications of chemicals, including enzymes, requests that exposure limits are established for enzymes. For enzymes, a DMEL value, which is short for derived minimum effect level, has been established. The DMEL value for enzymes is 60 nanogram per meter cube, which is a very low exposure limit. Now, while the DMEL value is a starting point, only should be used for the technical industries, this was changed in consequence of the REACH evaluation of alpha amylase. In the period from 2014 to 2018, the class of alpha amylases, which are extensively used in the baking industry, was evaluated under REACH regulation. The overall conclusion from these evaluations was that enzyme exposure must be in control in all industries for all enzymes, including the baking and other food industries. One reason for mentioning the baking industry is that approximately 80% of all registered allergies to alpha amylase come from the baking industry. By expanding the scope to all industries and all enzymes, the DMEL limit also covers the use of enzymes in the baking industry for all EU countries. In the Netherlands, an OEL for alpha amylase of 10 nanograms per meter cube has been decided in August this year by the Minister for Social Affairs and Employment. The overall implementation date for this OEL is 1st of January 2024. However, an extended implementation date is set for this sector the sector of raw material suppliers within the baking industry, so that the implementation date for this sector should be 1st of January 2029. But As the decision on this OEL stands right now, there are several unclarities, both in regards to the scope of the OEL as well as of who will be covered by the extended implementation date. So we hope that these unclarities will be solved in the months to come. Besides OELs for enzymes, most countries within EU do have a limit for the overall dust level, including flour dust. This level varies somewhat from one country to another, but an overview of existing limits can be found in the industry guideline on the safe handling of enzymes in the bakery supply chain. Here you can also find a list of regulatory exposures limits to subtilisin. To provide guidelines on how to handle enzymes in the bakery supply chain, the enzyme manufacturers in AMFEP joined forces with FEDIMA. The results of this effort is a 92-page document which is available free of charge from the websites of AMFEP as well as that of FEDIMA. This guidance document provides the insights and tools to help safeguard the health of workers in the baking industry, giving an overview of the steps that should be taken to mitigate the risk of the exposure to dust that may contain sensitizing materials. We have tried to cover as much as possible of the supply chain from the milling industry to the artisan bakeries. It is highly recommended that management and occupational health and safety staff read this document carefully to implement safety measures adequate for their industrial setting. Should there be any questions, you are welcome to forward these to the AMFEP-FEDIMA working group or to your enzyme supplier. We will update the document whenever relevant new information is available. It is generally known that safety information should be available in the local language and in a short and visual form. To meet this need, the AMFEP-FEDIMA working group has developed this poster holding the most relevant safety information for workers. The poster can be printed in A0 format, and it is designed to be posted in production areas where workers are often passing by. The poster is available from the AMFEP and the FEDIMA websites, and it is available in 12 languages. If there is a request for more languages, you can send the request to FEDIMA, and we will see if we have any option for providing such additional language. This concludes the introductory webinar. The main message that we want to convey is that enzyme allergies can be prevented if airborne enzyme exposure is in control. To get the enzyme exposure in control, you will need to address the 4 items listed: the process design and engineering control, work practices, respiratory protective equipment, and training and education. You can get much more information on this in the industry guideline on the safe handling of enzymes in the bakery supply chain. And you can provide direct safety information to your workforce by putting up the safety poster in a visible place in your production area. On this slide, you will also see links to other sources of relevant information on the safe work practices in the baking industry.
Okay, thank you very much, Merete, for this presentation. I hope everybody is still with us. We will now start with the question and answer session. So we'll try to answer as much as possible the questions that came in through the chat box. Just give us a few seconds to collect and then we'll start. And of course, if you still have any questions, don't hesitate to type them in the chat box.
Okay. I have a question here. Baking mixes contain enzymes. How has it been evaluated that these pose no risk to consumers? Um, Actually, you can find that the more comprehensive answer to that in this guideline document. It's been described very well there. But I know, as I was part of this study, what we did, we took several packages of these products and poured into a bowl where we stirred very vigorously in this dry product. We did that in a safety hood, I must admit. And then we measured simply the exposure by collecting air on by 4 pumps that were equipped with a filter, and these filter heads, they were put into the safety hood and placed directly above this bowl. And we did that mixing, the vigorous mixing, for, as I recall it, 15 minutes. So we simply set up a study where we tried to mimic the worst case scenario that we could foresee from a consumer.
Okay, thanks, Merete.
Yeah.
I see in the meantime some other questions were written in the chat to everyone. Can I suggest we take the question from Luis, which is, we use subtilisin in our factory. We need to measure the concentration of subtilisin in air, but we do not find any laboratory who makes us the measures.
Okay.
And the question is if we know any laboratory in Spain who could measure the concentration of subtilisin in air.
Personally, no, I don't, but I would recommend you to contact your enzyme supplier, who most probably would be able to help you. So that will be my immediate answer to that question.
Okay, thank you, Merete. Another question from Federica, who is a formulate improver. Can you suggest a maximum concentration level to reduce the handling risk for the clients?
Well, I would say that if you keep below the 60 nanograms per meter cube, which is constituted as a DML value in Europe, then I would say that the risk of sensitization and allergy is very, very low. We have established this DML value of 60 nanograms per meter cube based on 40 years of historical data from the enzyme manufacturing industry, and we will see there that if you keep your average exposure below the 60 nanogram per meter cube, then the incidence rate, that would be new cases of allergies among the workforce, will be very, very low, very low. One in 1,000.
Okay, thanks. Hope that explains. We have another question here that we received in writing. The question is, when a safe OEL of 60 nanogram per meter cube is okay or accepted for subtilisin, can we then safely assume that this limit also holds for other enzymes?
The answer is yes. We have seen now throughout monitoring enzyme exposure and health surveillance for more than 40 years that there is no reason to believe that you should have any variation between enzyme and enzyme classes in regards to the potency. So if the 60 nanograms per meter cube is okay for one enzyme, then it will also be okay for others. Any variation will not between enzymes will not have any impact. It will be so low, such a variation, so it will not have any impact on whether you should put it up as 60 nanograms per meter cube or 58 nanograms per meter cube. So it is within the standard deviations.
Great, thank you, Merete. I see another question. Why is everybody only talking about amylases? Is that because it is not possible yet, between brackets, to analyze other enzymes in dust?
I guess the reason why everybody is talking about amylases is due to the fact that amylases are so widely used within the baking industry and not so much the other enzymes. But and I guess another reason would be that we have had this investigation in the Netherlands now for 5 years as to set an OEL for alpha amylases, and also the fact that the REACH evaluation of enzymes took place on alpha amylase. So by that, alpha amylase has been very much in focus, and it is also it's also okay to talk about alpha amylases as the focus area due to the high tonnage of alpha amylases used within the baking industry. When this is said, it is not because that we are unable to measure for exposure to the other enzymes. We can do that. It is the same principles as for alpha amylase. So both health monitoring and airborne exposure can be measured for other enzymes as well.
Okay, all clear. Thank you. I see another question that came into the chat. Am I correct in concluding that enzymes as a sensitizing agent is the only significant health hazard for workers, I assume that is?
The short answer is yes. If you look, if you look at the toxicological profile of enzyme, the only important endpoint is the sensitization by inhalation. There is also for the group of enzymes that are proteases, that is enzymes that are able to break down protein. Proteases, they are able to cause skin irritation. If you have any contact in high concentrations to your skin for a long period, then you will see a skin irritation. But it is not it is a transient effect, so it will disappear when out of exposure to the skin. So it is very important to stress that we are talking about skin irritation and not skin sensitization. These are two different effects. The skin irritation is transient, whereas the skin sensitization is a permanent condition. So for proteases, you should also look at skin irritation, and that is avoid any skin contact.
Okay, thank you. I see one more follow-up question that we got, which was based on the question when the OEL of 60 nanograms per cubic meter is considered safe, then what has led the Dutch authorities then to pose an OEL of 10 nanograms per cubic meter? Do you have insights on that?
I would be very happy if I were able to give a very specified answer to that. I think what has led the Dutch authorities to come up with a 10 nanogram per meter cube OEL is that they are very ambitious, and according to what they have put up is that they have some sort of a calculation model that is not publicly available, but they would like to set up a risk profile that only if you are exposed to the enzyme in your working condition, then you should only have 1% extra risk of becoming sensitized compared to the population outside the working place. And it is very difficult for us who is working within this area to explain how they came to this proposal in the first place, simply because you do not get exposed to industrial enzymes outside your working place. So I'm afraid I'm not completely able to answer that question.
Okay, that's already good enough, I would say. In view of the time, I would like to propose I will answer one more question, and I think a very relevant and practical one was asked earlier in the chat, is when the webinars will be available to download, as we said at the start. And that I can answer to everyone directly. That will be on the FEDIMA and AMFEP websites later this week for download. With that, I want to close the Q&A session for this webinar. And of course, should you have any questions that come up after today or while reviewing the materials that we have available publicly, don't hesitate to send us your questions to either AMFEP or FEDIMA at the emails that are on screen right now. Before we close, just a reminder for the next webinar, which will take place on the 29th of October, same time, and it will be dealing with the control of exposure in the bakery sector, but specifically for artisan bakeries, bakery schools, and demonstration bakeries. Thank you very much for your participation today. We had people attending from many different countries, so that is great to see. And last, thank you to our partners who helped support and promote this webinar series that we are organizing. So I hope to see you at the next webinar, and thank you very much again for joining today.